Okay, hi everyone. Welcome to my channel, Math Made Easy with Query in 10 minutes. Okay. All right. So the next part now. In the previous video, I defined what domain is. I defined what range is as well. Okay. So now I'm gonna go straight now into domain. I'm gonna use this part to finish up domain and also just briefly talk about range. Then the next video, we're gonna solve examples and solve questions on it, okay? So the essence of the previous video and this video was to just lay the foundation. Then after laying the foundation, then we're gonna go and solve some questions. All right, let's start then. So if you have, we talked about domain, and I told you domain is all the possible permissible values for x that the function can process. So how do you write domain? Okay, there are two ways of doing it. You can either use what we call the interval notation. It's called the interval notation, or you can use the set notation. Okay, so any of them is fine. Okay, they are very similar. Okay, but it's just that for the interval notation here, we use brackets. Okay, so we use brackets here to clearly define or imply where the function is defined. Okay, while here from the word we use set. Okay, to clearly state where the function is or not defined. Does that make sense? So here we use brackets. The first one is we use brackets to imply where the function is defined. Okay, please don't forget that. We use brackets to define where the function, we use brackets to imply where the function is defined. All right, we use brackets to imply where the function is defined. But in set notation, here we use set to state perfectly clear where the function is or is not what defined. All right, let's go back to that example we had. All right. In the previous video, I had an example where we said I think it was y is equal to 1/x. I think in the previous video I did y is equal to 1/x. Okay. So let's work with this example now. All right. They want to write it that. So I'm going to use with interval. Now in interval notation, okay, remember I said interval uses brackets, okay? So that means interval is written in this way. You're going to write the domain is. So remember we said all the possible values of x are permissible here except 0. Do you remember where we, in the previous video, for those that did not watch the previous video, you need to go back. So where we found out that we can plug in any number into this and the function can process it except 0, okay? So remember, I'm feeling like I should just write how the bracket, each of the definition is, so that will help you to understand. So this, we said it uses brackets, okay, to clearly define where, or clearly imply, or let's just say, let me just use imply, okay? So to imply clearly, okay, where the function is defined. Okay, so basically, in interval notation, we use brackets to clearly define or imply where the function is defined. Now, but this is different for set notation, where I said set is used to state perfectly clear where the function is or not defined. So basically, we use set to state perfectly clear or where the function is or not defined. Okay. All right. So now having this definition in mind, okay, having it in mind now, let us answer this. So remember I told you that all numbers are permissible here except 0. So how do you write it? So that means we use brackets to imply where the function is defined. So that means you can use all numbers from infinity Minus 1 million can work here, minus 2 million, minus infinity, all the way to except what? 0. Then from 0 all the way to what? Infinity. So that means how are you going to say this now? So this can be clearly say that we plug in any value from negative infinity to up to 0, but not including 0. So you can see we are using curly bracket here. Okay? So that means when you put something like this curly bracket means 0 means it's not part of the answer. This curly bracket here also means that 0 is not part of the answer. So you can see it means that you can plug in any number from negative infinity up to 0, but not including 0 into the function. And this U means and, it's a union, okay? And you can plug in any number from 0, not including 0, up to what? Infinity. Is this making sense? So this is how you write domain, okay? Using interval notation. Now, for the set notation is quite easier. So personally, I prefer to use the set notation because the set is straightforward. So the set, how you have written it with a set is that you write it like this, the domain, okay, for x is any number except x to be equal to what? 0. Can you see? So you see this is straightforward and straightforward. So you can see the domain is any number for x, provided that x is not equal to 0. So this vertical line means such that. So you can check some textbooks, they'll call it such that. So that means D is our domain, okay, for all values of x, such that x is not what? 0. Hence, everything else is okay. So what remember I said is what is defined and not defined. You have to state clearly, okay? So it clearly states where is defined and not defined, all right? So that is how you write the answer for this. So remember this particular example, if you're using the interval notation to write it, this is how you write the domain. If you're using the set notation, this is how you write the domain, all right? Good. All right, so the next thing we can do is I'm going to solve more examples in the next video. All right, I'm going to solve more examples in the next video because I'm already approaching the 10-minute mark. But one of the things I wanted to just quickly talk about is the range. Okay, the range. Remember we talked about the range are all the values for y that corresponds to the domain. All right. Now to determine the range is a bit tricky, and it's a bit tricky in that we might need to draw the graph. So usually what I do is I draw the graph, and from the graph I can predict the values for x, okay? So for instance, in that same example, we have y equal to 1 over x. We've already established what the domain was. We said the domain is all the values for x, okay, except such that x is not equal to what? 0. Does that make sense? We talked about this already. Now, but for the range, now if you plot the graph for the range, you will notice that the range as well is all members of real numbers except y. Y can never be equal to 0. Okay, so we've talked about this already. Okay, we talked about this already for the domain, but for the range, the best way I can explain the range is by if I solve some examples, okay? Because this is the bit tricky one. Usually, the best thing to do, the first thing you do, you draw the graph, and from the graph, you can now predict what all the possible values will look like, all right? But first thing first, what we talked about in this video, talk about the domain. So for the domain, we have two types. We have the interval notation, and we'll talk about the set notation. So for the interval notation here, we use brackets, okay, to imply where the function is clearly defined. But for the set notation here, it's quite different. Here you use set to state perfectly clear where the function is or is not defined, all right? And I use the example of y is equal to 1 over x. So for an interval notation, you write a domain is any number between negative infinity up to 0, not including 0. and from 0 to infinity, not including 0 as well. Can you see? But the set notation is a little bit easier for me. You just say the domain is all possible values for x such that x is not equal to 0. So this is the way you write it here, okay? And that was that. So I also talked about the range, and I said for the range as well, you need to keep in mind that the best way to do the range, because it's a bit tricky, you need to draw the graph. But when you draw the graph, you will see the answer. So I'm going to talk about the answers. How do you get to this answer in the next video? So I'll see you in the next video where we'll take some examples, and I'll pick some examples and explain to you how to go about them. All right. Thank you very much, and I'll see you in the next video.